All right, this is our last column. So if you're with me, then it's because you need some assistance in going over the last column from 27 to 38. These are much more involved than the other ones. So we want to make sure that you understand each one 100%. Number 27 is x to the negative 1 over x to the negative 8. And what's going to happen here is we have two sets of negative exponents. What has to happen is our negative exponent that is downstairs needs to come upstairs and become positive. Meanwhile, the one that is upstairs needs to go downstairs to become positive. So basically, we're just going to do a reciprocal. So upstairs is then going to become x to the positive 8, and downstairs is going to become x to the first. At this stage, we have like bases, and they are going to subtract their exponents because of the division. So this is just x to the 8 minus 1, which is x to the 7th. 28 is 52 x to the 6th over 13 x to the negative 7. So the first thing I want to do is, honestly, I want to take a look at that 52 over 13. So the reason why I want to look at that is because this is still a fraction, and I want to reduce that fraction. So I'm going to do 52 divided by 13 and see if it's a common factor. And it is, and it's 4. So this is going to reduce to 4 in the numerator. Then I have x to the 6th over x to the negative 7. Now there's two ways to handle this. You can either do the same base and subtract the exponents, in which case you would have x to the 6th minus negative 7, which would then give me x to the 13th positive to get your answer. Or you could do it this way. You could take, let me give you an or scenario. Or, we're here, you can take your x to the 7th and bring it upstairs to make it a positive exponent and have it sit right next to that x to the 6th power as a positive exponent. And we know, oops, that should be an x. And we know that they have like bases, so you would add these if you're multiplying, and you would still get 4x to the 13. So you can either take these and subtract because it's a division problem. Just remember that you're subtracting a negative, which would become a positive. Or you can bring this negative exponent upstairs with the x to the 6th and then combine them by adding the exponents. Either way, you end up with the same answer. Number 29. Almost skipped one. You have f to the negative 3rd times f squared times f to the negative 3rd. Now, what's interesting about this is these are all being multiplied, and they all have the same base. So we're basically going to add these exponents together to get our final exponent. So that's f of f to the negative 3 plus 2 plus another negative 3. Well, that's going to give us f to the, what is that, negative 6, so negative 4. And of course, we can't leave this in negative exponent position, so we are going to put it over 1. We're going to slide this downstairs, and we're going to have f to the 4th downstairs and a 1 upstairs, and that's your final answer. Next, we are on number 30. Where's my pen? Lost my pen. Number 30. Number 30 is x to the negative 4 over x to the negative 9. This looks very familiar. This one actually looks just like 27. And the fact is that there are a couple ways to do this, but the most important thing to realize is that if you know your rules, you can navigate through pretty easily. I'm going to bring this negative exponent upstairs. I'm going to bring this negative exponent downstairs, and I'm going to create positive exponents to work with. So that's going to give me x to the 9th over x to the 4th. Once I do that, I have a like base, and I'm just going to subtract these. So my final answer is x to the 5th. Number 31. We've got 24x to the 6th over 12x to the negative 8. So this one is a fraction. This one looks very much like 28, actually. What we're going to do is we're going to tackle this fraction first by reducing this fraction. And when I reduce that fraction right away, 24 over 12, I'm going to get 2. And that's a numerator because it's a whole number 2. Then, again, we've got two positions we can do. You can either keep the same base and subtract your exponents, which would be 6 minus negative 8. And that would give us 2x to the 14th. Or, just like the other one, you can bring your x to the negative 8 upstairs with your 2 and your x to the 6th. And when you multiply, you keep the base and you add the exponent. You're still going to get 2x to the 14th. So it doesn't matter whether you do the subtraction rule for the quotient, or whether you do your negative exponent rule and then do your multiplication rule with your sum of your exponents. Either way, you end up with the same answer. 32. Okay, so 32 is similar to 31, but it's just got one little difference that we need to look at. This is 3x squared, y to the negative 3 over 12x to the 6th, y to the 3rd. And I think the biggest thing, honestly, is reducing these fractions. So when I did 24 divided by 12, that's legit a 2, a whole number 2. But when I have to reduce 3/12, that's not 4, it's 1/4. So we need to acknowledge that this is 3/12 reduces to 1/4, okay? Then what we can do is we can do our quotient rule by taking the same base, which would be x, and subtracting 2 minus 6. That's going to give us a negative 4. And with the y's, we're going to keep the same base and subtract negative 3 minus 3 is negative 6. So we're going to take and keep the base, subtract the exponents. That's where these come from. But this is obviously not the final answer because we don't have negative exponents as answers. So what we need to do at this point is we're going to take these and move them downstairs, so that the only thing that's left upstairs is a 1. And downstairs has a whole number 4, an x to the positive 4, and a y to the positive 6. And this is your final answer. Okay. I need to get a next piece of paper. We're going to do 33. We're going to finish these strong. Let's go to 33. 33, you have 2x to the 3rd, y to the negative 3rd, all raised to the negative 2. So like the other ones, the first thing I want to do is simplify everything on the inside of the parentheses. Okay, so there's no fractions to reduce, but I do have a negative exponent on the inside that I want to handle. So I want to take this y to the negative 3 and I want to bring it downstairs. Okay, and that's going to give me a positive exponent in everything inside my parentheses. So I'm now going to have a 2x to the third over a y to the third. And this whole thing is going to be raised to the negative 2. Now, there's a shortcut that I want to show you, which is pretty neat. When you have a negative exponent on a fraction, when this is the outside and this is a negative exponent on a fraction, the quickest way to get rid of that negative exponent is to take the reciprocal. So I'm going to change this because I'm going to get rid of this negative exponent now. So you take the reciprocal of the fraction on the inside. So what that's going to transform into is y to the third over 2x to the third, because I'm reciprocal, so I'm going to flip it. And then I'm going to raise this all to the positive 2. So that's what you do to get rid of a negative exponent on the outside of a fraction. You take the reciprocal of that fraction. Now I can distribute that exponent to everything on the top and everything on the bottom. So this is going to turn into y to the third squared, 2 squared, and x to the third squared. So this gets a square, the 2 gets a squared, and the x to the third gets a squared. Remember, power to power, you have to multiply. So that's going to be y to the 6th. 2 squared is 4. And power to power, x to the 6th. There's your final answer. Now, sometimes you can put a 1 there. Like sometimes there's going to be a 1 there, but it's not necessary. But the 4 does have to be in the denominator on this one. Moving on to 34. This is another fraction that we are reducing. We've got a 2x to the 4th, y to the negative 4, over 8 x to the 7, y to the 3rd. We just double check it. 2x to the 4th, y to the negative 4, 8 x to the 7, y to the 3. Okay, so what we're going to do is we're going to reduce the fraction first. And again, we're reducing 2/8. This is going to be 1/4. Okay, we're going to take our x's, same base, and we're going to subtract those exponents, top minus bottom. So that's going to be x to the negative 3. And then we're going to take this set of exponents and same base, subtract, and we're going to get negative 4 minus 3 is negative 7. So that's how that one gets started. So we reduce the fraction, subtract down, subtract down. Now, because there's negative exponents, we need to make sure that we relocate them to the correct position. So this negative exponent comes downstairs and this negative exponent comes downstairs. So our final answer for 34 is 1 over 4 x to the positive 3, y to the positive 7. 35. We're almost there. 35. We've got 4x to the 4th, y to the negative 4, all raised to the 3rd. So again, I'm trying to simplify everything on the inside of these parentheses first. and I realize that I have a negative exponent that needs to move downstairs. So when I go to rewrite this, I'm just going to have 4x to the 4th upstairs, and downstairs I'm going to have y to the 4th, and that's a whole fraction, and that's raised to the 3rd power. Now, if you look real quick up at 33, this one had a negative exponent, and that's why we took the reciprocal. This one, however, is not a negative exponent, so we're not taking the reciprocal. We just simply have to distribute the exponent to all of the terms. So this is going to turn into 4 to the 3rd. X to the 4th has to be raised to the 3rd. And y to the 4th has to be raised to the 3rd. So our final answer, 4 to the 3rd, is 64. Multiply x to the 12th. Multiply y to the 12th. There's your final answer for 35. 36. Whew. Okay, this is just a multiply. It just looks aggressive. We're going to talk about it. Okay, so this is really one term being multiplied by another. And what indicates that it's a multiplication is this set of parentheses. They could have put a dot in between. They could have put parentheses around both of them, but this is just a multiplication. So we're actually going to start with multiplying the coefficients. So we're going to multiply 5 times 2. And 5 times 2 is 10. With our exponent rules, if we are multiplying and we have the same base, we are going to take the base and keep it, and then we're going to add these exponents up. We are going to take said same base, and we are going to add these exponents up. So this is going to turn into 10 x to the 6th, y to the negative 2. Last step, though, got to bring that one downstairs because it's a negative exponent. So our final answer for 36 is 10x to the 6th on top, and the y squared moves down. Boom. All right, 2 more and we're there. And these are big. So stay with me. 37. Holy cow. Okay, negative 7. A squared. B to the 3rd. C to the 0. Over 3. A to the 3rd. B to the 4th. C to the 3rd, all raised to the negative 4. Now, there's a lot going on there. But I have to tell you, we can clean this inside up real quick. The first thing we're going to do is take a look at the coefficients. Unfortunately, I can't reduce this. So that's just going to stay put. I'm going to rewrite this. I'm going to skip a space so that there's some room because there's some stuff over here. So this just comes back down again and make a nice long line. Okay? Then I'm going to take a look at my A terms. Same base. Subtract down. That's going to give you a negative 1. B's. Same base. Subtract down, that's going to give you a negative 1. C's, same base. Subtract down, that's going to give you a negative 3. Be careful of that. 0 minus 3 is negative 3. And all of that is contained to the negative 4th power. So the first thing I did was I just did quotient, quotient, quotient. Got them all in simplest form here. Now I have to take and relocate my negative exponents. Now negative 7 is not a negative exponent. This is just a number. So that doesn't move. A lot of people think because you have a negative coefficient that has to move. It's only negative exponents that move. So my a to the first comes down. My b to the first comes down. My c to the third comes down. So what this is going to turn into is -7 on top and a 3, a to the first, b to the first, and c to the +3. That's what this inside turns into. And then we're going to raise this all to the -4. Okay? Whew. Take a breath. Remember back up on 33. Now, when you have a negative exponent, you are going to take reciprocal of the fraction and turn it to a positive exponent. So we are going to take our negative exponent and we are going to take the reciprocal. So what that does is it basically turns my denominator on the top, my numerator on the bottom, and that's all being raised to the +4th power. When you take your negative exponent and you take the reciprocal of the fraction, it changes your negative exponent to a positive. Now I've got no negative exponents here. That means that I can start to distribute all of my to the 4th powers to every piece in this puzzle. So check this out, because it's going to take me a little bit of time to write it. I'm going to have 3 to the 4th, a to the 4th, b to the 4th, c to the 3rd, all to the 4th. That's what the numerator looks like. All over -7 to the 4th. Now we have to do some math. 3 to the 4th, I believe, is 81. A to the 4th, b to the 4th. You're going to multiply power to power, so that's c to the 12th. And -7 raised to the 4th power is 2,401. And that's how that answer happened. Boom. And we are on our last question. And it looks just like 37. Just like it. So let's see if we can do this. I think I can do it over here. All right. This is 38. All right, 38. I got, in parentheses, -2, a to the 3rd, b squared, c to the 0 over 3, a squared, b to the 3rd, c to the 7th, all raised to the -2. So the first thing we're going to do is we're going to break this down piece by piece. -2/3 does not reduce. So that is going to stay -2/3. I'm going to write it over here, though. Okay? I get this big fraction. Then we're going to do our A's. Same base, subtract, we get 1. B's, same base, subtract, we get -1. C's, same base, subtract, you get -7. And that's all raised to the -2. Next step, I want to bring my A down, or I want to leave my A, B. First of all, leave my A alone. This is a +1. We've got to leave that B. But the B needs to move down, and the C needs to move down. A stays put because it's already a positive exponent. This -2 stays put because that's not even an exponent. That's just a number. So we're going to begin with -2a to the 1st on the top. And on the bottom, I have a 3. a b to the first, and a c to the seventh. That's what this turns into. And all of this is going to be raised to the -2. Next step. Negative exponent on the outside of a fraction means that you have to take the reciprocal of the fraction to get rid of that negative exponent. So 3bc to the 7th over -2a, all raised to the +2. And then we can start distributing that squared. So this is going to be 3 squared, b squared, and c to the 7th squared. This is -2 squared and a squared. All right, so we're ready for our final. 3 squared is 9. B squared, multiply, that's c to the 14. Bottom, -2 squared is +4 with an a squared on the bottom. And there is your final answer for 1 through 38.